set this for 20 minutes. Set, start. Okay, so now that we've done that, if I run this code again, I'm going to expect an error message in my code instead of just looking in the debugger and getting a null for that location. So let's refresh our empty cache hard reload, and then F12. And if we look at the console, I screwed up something. Semicolon. There we go. Okay, now we'll refresh. Okay, and we can get rid of that breakpoint, and we'll missing the play button. Oh, there you are. Okay, so we have the error message down here. So I'm going to just put the breakpoint here because I'm expecting that to get flipped, and I don't know how to. Oh, yeah. So gotta split the screen like that. Okay, so now if we do this, okay, so now I'm seeing that this is getting thrown because that location is null, which I kind of expected. Has location is flagged because, you know, we already flagged it as supposedly existing, but we didn't. But that's just because we fetched it. Okay, yeah. So that's good enough. Like I'm happy with it. Finding the problem like that. Nice obnoxious little error message. Error. Does uniform exist in shader? And with that, okay, we're asking a question if does that uniform exist in the shader? We could put a question mark. We should probably put a question mark. That would make it a little bit understandable. Does uniform exist in shader? Because that is our question mark. And then within our shader code, way up here, where are you? So the has memory, that's for our fragment shader. So the fragment source. And if we look at our variables, we got our sampler, no, that's precision, in. Okay, so we have this uint that says has mem, and I believe that's what we called it. But the thing is that we don't have, alpha value. We don't have any type of condition in here that makes use of that, so it got optimized out. Now, one way we could easily fix that is, right, and this is something that could break quite often, right? Because if we use it and then we decide not to use it later, right, and it's just going to keep on getting optimized out, and that error. So that's a very useful error that we added because chances are, even after we fix the problem, it could get rebroken, right? And that's why I like to make sure that before I fix the error, I add error checking code that's going to pick up on the problem. Because if the error happens, there's always the potential for that bug to re-pop up again, and you want to make it as easy to find as possible. Okay, so if the has mem is greater than 0, and if that is true, and actually we're not going to worry about the putting it into a string yet. We'll just write it as normal, and then we're going to wrap it in a string after we've thought about it. So alpha value, and we'll just set the alpha value equals like a 0.5 to make it kind of transparent. I don't know if that's gonna I don't think that'll make, well, we should see something. So let's just give that a shot. So if hasmem is greater than 0, we'll just do that, right? Just to see if we can now fetch the uniform value, because we are now using it in the shader, right? And so 1, 2, 3, 4, 1, 2, 3, 4, get that aligned. Okay, and if we go to our code now and we refresh, I'm gonna hope that, come on. Wrong operand types. No operation exists that takes a left-hand operand of type uniform high p uint and right-hand operator of const int. Really? So what the fuck do I gotta... So I guess just 0. OpenGL does this weird thing where it's like really strict about its types. Like it doesn't, unlike C code, it doesn't have like that implicit casting. So let's try to yeah, let's try to I don't know, declare uint web uint glsl, right? So we need one way is we could probably just use a constructor to fix it. Right, so we're gonna, like, when we write the value, we have to, like, wrap it. Yeah, whatever, whatever. So over here, we're gonna just say, for this 0, we're just gonna say, uint 0 like that, which is kind of ugly. It does give us more information, though, right? Because now we know the type is a uint, but we knew that from up here, so it's... I don't think GLSL penalizes you as much for constructors as you may be accustomed to, because I see people do stuff like this all the time, especially like, right, vec4 constructor here. Like, I think GLSL is pretty optimized in terms of the way it works with constructors. So I don't think that is a penalization using the constructor instead of a cast, right? So instead of casting it, I used it in a constructor. I think that's totally valid, though. So let's give that a run. And looks like we're good. Looks like... well, we're not quite good. Something's... what the hell? Empty cache, hard reload. Uniform 1U is not a function. Okay, so uniform 1U. So I'm gonna assume that what that is about is I was taking a guess at what that should be, and I am wrong. WebGL uniform 1U. So there's possibly that's called uniform 1UV, or maybe it's just called uniform because this is WebGL. And this is all uppercase. Okay, so our functions are alphabetical, so that's nice. So we can kind of like A, B, C, D, G. Okay. I was just looking at it. How does that work? How the fuck? So, yeah, the debugger in Chrome, it's better than Firefox's, but sometimes it does things that are annoying as hell. Like, I didn't mean to... like, I don't know what I did. I think, like, you know, I'm hovering over here. I've painstakingly, you know, scrolled down here, and now I don't want to lose it. Okay, so there's one F, one FV, one I. Oh, so it's one UI, it looks like, right, for unsigned integer. And so now that we know that's one UI, what I'm concerned about is this one U. Is that just OpenGL and not WebGL, or did I make that up? So uniform one U. Not really good results. Maybe if I put a UI, I'll. Okay, now I get some results, and I even get 3F, 2I. Okay, UI. It's definitely. Yeah, I totally made that up. There is no 1U. So we'll go and we will go in here and we're going to look for uniform 1U and see where we're using that. Okay. What the? Okay. Yep. So I even made a note in the comments. So for whatever reason, I think I don't know. So for whatever reason, for whatever reason, I thought it was UI. I don't know why. But okay, so let's go over here. Let's close this. And let's empty cache, hard reload. Okay, yes, that is a function that actually exists. And now if we put a breakpoint here and we keep on going, we should see some type of value that makes more sense. So the value is 1, but that's what we set. And then the location, WebGL uniform location. So instead of just getting integer, we get this weird ass thing where it doesn't. If we go into the prototype, can we find? Yeah, so it's just as far as I'm concerned, this is slightly more obtuse than the C code version of this, but whatever, that's the way it works, and we got something that isn't null, so that's good. And you know, so we are assuming that we're setting that 1 in there. Let's keep going. Okay, so we got that. Let's look at the console. Console isn't complaining. All right, cool. So now that we have that kind of all set up and we're kind of like organized, the next part is to sample from the textures that have been uploaded, and so the main memory and the ISO memory. We're gonna try to just do it from the ISO memory first, because that's a 512 by 512, and that's what we've been working with in the other code. And all we want to do is get a shader that's gonna go over the pixels in the ISO mem, the 512 by 512 texture, and just kind of paste it onto our quad. And speaking of our quad, why is it? Oh yeah, because it's 640 by 480. So it might be like stretched. We're gonna sample. But we're just gonna do what we can do to sample the pixel values. Using hopefully a texel fetch, and then after we have the texel fetch, we want like a get and set pixel, and we'll want a like canvas adapter object, and the canvas adapter will actually contain the adapter graphics, I believe. Right, because the canvas adapter is another layer of abstraction in the way we've done this. So like in the global classes, right, we'll have after the adapter graphics, we'll have the canvas adapter, and the canvas adapter will actually hold a reference to the adapter graphics. That seems a little bit obtuse, But the idea is that we have that canvas adapter as like this, barrier between the implementation and it's encapsulating the implementation, right? So that it's easier to refactor things out and change the implementation. Even though, this adapter graphics object itself is kind of like encapsulating stuff, but if you look at it, if you look inside adapter graphics, it has a lot of very WebGL specific stuff, and the canvas adapter was supposed to be like this generic thing that maybe it's a HTML5 pixel-based canvas, or maybe it's a WebGL canvas. So it still makes perfect sense that we have this other container that's the canvas adapter that will hold a reference to this object. So we have to declare, we got to be careful about how we're doing it, because we got to, we'll put it down here, and then we initialize it after initializing this, right, so that we can get a reference to it. Yeah, that'll be fine. Okay, so I'm gonna stop recording this, and then I'm gonna maybe do a little bit of research on Texel lookups, and then I will start recording how we're gonna get the Texel lookups.